Welcome to 9-1. Our learning goals are going to be, can I convert radians to degrees and vice versa? And can I find arc length of a circle? We're going to start off with the fact that all circles are similar. So in previous chapters, we learned about angle, angle, side, and side, side, side to show that all triangles could be deemed congruent, and then also similar. There is no theorem like that. All circles will be similar. There are no angles, and all I have to do is multiply the radius by a scale factor to go from any circle to another circle. On page 623, we're going to read that in a circle, the degree measure of an arc is equal to the measure of the central angle. Arc length is the linear measurement that represents a portion of the circumference of a circle. To determine the arc length of a minor arc, you need to know the circumference of the circle, which requires knowing the radius of the circle. So the arc length is going to be from A to B, like this, but if it were stretched out straight. So I could get a string, measure that, put on a ruler, and measure it. So here I have two circles. They're similar. The angle is the same, and the arc lengths would be proportional. So how do I find this? Well, there's going to be some equations. Arc length will be represented by the variable of s. So s is going to be the central angle, which is the fraction of the circle, times the circumference divided by 360. Or represented as this, s equals the measurement of the angle divided by 360 times 2 pi r. So I'm going to do a couple for us. So I'm going to have my s equals the measurement of the angle, which is 80 over 360 times 2 times pi times r, which is going to be 20. Now this says leave in terms of pi. So if I put pi in the calculator, it's going to give me an answer that has a decimal in it. So I can use my calculator, but I can do 80 divided by 360 times 2 times 20, and that's going to give me 8.8 repeating. So I'll go 8.8 repeating, and then I'm going to put my pi there. I could leave this all as a fraction too, and I'd have 80 times 2 times 20, which gives me 32,000 over 360, and I could simplify that by canceling that out. I know it's divisible by 4. So that's going to be 9, and I'm going to have 80 over 9, and I don't think that goes in there anymore. Got another one for us. So we're going to have the same radius. So I'm going to have a different central angle. So I'm going to have 120 over 360 times 2 times pi times 20. And then I can put 120 times 2 times 20 in the calculator, get 4,800 over 360 pi. Oh, that should have a pi there. Forgot that. And if I wanted to, I could figure out the decimal version of that, which would be 13.3 repeating pi. So I'm going to have you guys try this one. Remember, you got to have pi in the equation, so don't have a calculator where you put pi in. Welcome back. So here I have my equation. I did the central angle over 360 times 2 times pi times 10. I was able to say, well, I recognize that this is 1/3 as a fraction. So rather than multiply 120 by 2 by 10 and have to divide by 360, I simplified this to 1/3. Then I did 2 times 10 to get 20, and that makes solving a lot easier. So I got 20 pi over 3, or 20 over 3 times pi, which the decimal version would be 6.6 repeating times pi. Okay, now we're going to learn about radians. So far you have described the measure of angles and arcs using degrees, and determined the arc length intercepted by a central angle as a linear measurement. Let's investigate another unit of angular measure called a radian. 1 radian is the measure of a central angle whose arc is the same as the radius of the circle. The radian measure theta of a central angle is the ratio of the length of the intercepted arc to the radius of the circle. The length of the intercepted arc of the central angle is proportional to the radius. So here are going to be my two new equations for finding the central angle or the arc length. So if I have arc length, if I want to find arc length, I just take the radius, not the radius of r, and the angle measure in radians, and multiply those two numbers together. If I want to find the radian to measure, I take the arc length and divide it by the radius. We did an activity like this in the classroom where we took a piece of string, which was the radius, and you guys layered out. You did 1, 2, 3, 4, 5, 6, and there was a part of 1. So that part of 1 is going to be 0.283 parts. That number doesn't mean much to you, but if I take 6.283 and divide it by 2, I get 3.14, which is pi. So this is relating to pi. Pi is actually the number of times a diameter goes around a circle. And if I think, oh, diameter, that's just 2 radiuses. So I could take a 1 diameter, oh, that wasn't very good, 2 diameter, 3 diameter, and 0.14 of a diameter. So radians relates to pi. You're always going to have pi in your answer. So, and you're not going to be using 6. You're going to have like 2 pi or pi over 2. So radians are measured in with pi. So if I'm looking at which is bigger, a radian or a degree, well, there's 360 degrees in a circle, and there are 2 pi radians. And for sake of understanding, we can say that's about 6.28. So if there's 360 degrees or 6.28 radians, well, a radian would be much bigger. A radian is going to be about 55 to 60 degrees of in a circle. So let's figure out how we can convert radians to degrees and degrees to radians. From the previous page, we know that there's 360 degrees in a circle and there's 2 pi radians in a circle. So I'm always going to be using the conversion factor of 180 degrees equals pi radians. So I'm going to either multiply it by pi over degrees or multiply it by degrees over pi. So for this worked example, I want to get degrees to radians. So I have to put my degree on the bottom, so the degree symbol cancels out. Then I take 60 over 180. I can cancel those zeros out, and I can see that 6 goes into 8 3 times, so I can get 1/3 pi, or just pi over 3. I'm not going to use a decimal approximation to convert radians to degrees. Do not put this in the calculator. I do not want you putting 0.3 repeating pi radians. I do not want you putting what that would be in decimal, 0.3 times pi on the calculator. .9. I do not want 0.942 as an answer. I want the answer to have pi in it and be in fraction form. If I'm going to convert from radians to degrees, I'm going to use the same 180 equals pi ratio, but I'm going to have pi on the bottom. That way pi will cancel, and then I just have 180 degrees divided by 3 gives me 60. If I want to use my calculator on this one, that's okay to use the calculator on this one. So let's figure this out. How many degrees? 1 degree is how many radians? So I have degrees. 1 degree is going to equal pi over 180 degrees. That way the degrees will cancel. And then it's going to be left with pi over 180. which that makes sense. That's the conversion we're using. And then degrees in 1 radian. Well, if I have 1 radian, I'm going to multiply that by pi 180 over pi. I'm going to have 180 over pi. And then since it's degrees, I want to put this in the calculator. And I'm going to get 57.296 degrees. So 1 radian is much bigger. It's 57.29 degrees. Now that I know all about radians, I got to sort of figure out, since I can't use decimal versions, let's figure out what some common degrees are in radian term. So if I start here and I go all the way around the circle, it's either 360 or 2 pi. So if I went halfway around the circle, this would just be pi. If I went a quarter of the way around the circle, that'd be pi over 2. And if I went 3/4 of the way around the circle, that'd be 3 pi over 2. So these are numbers that we're going to need to know, and there'll be a thing called a unit circle. We're going to have more numbers because this is a radius of 1 going around. And we're going to know what it's going to be if it's pi over 4. What if it's pi over 6? And there'll be numbers out here. And we'll get to that later. Okay, so now we're going to get to actually figure out some angle measures with radians. So to figure out your theta, you take this arc length, which is s, divided by your radius. So simple math here. I'm going to take 12 over 18, and that's going to reduce down to divide by 4. No, not 4. I guess I can divide by 2. And I get 6 over 9, which then I can divide by 3. And I can get 2/3. So this theta equals 2/3. Over here, we have to then calculate what s is using this theta, since all circles are going to be similar. So I can take this equation, but that's not the equation I actually want to use, because that's got a lot of extra stuff. This is for degrees. So I'm going to take this equation and I'm going to change it to I'm going to multiply each side by r. And this equation was in the presentation before. S equals theta times r. I know my theta is 2/3. I know my radius is now 6. So I'm going to get 12 over 4. And my arc length is going to be 3 centimeters. And this math is much easier than doing it this way, because I have a ton more numbers. It's just 2 numbers being multiplied together. So this we have then the measure of a central angle is 120 degrees. The length of the radius is 20 centimeters. Determine the arc length using each equation. So I can do that. I can do 120 over 360 times 2 times pi times radius of 20. That's going to give me, this is 1/3. So I'll simplify it out, and I'm going to get 40 over 3 pi. Now, I want to convert 120 degrees into radians first. So I'm going to divide by 180 degrees, times it by pi. The degrees cancel, and I'm going to get 120 over 180. Zeros cancel. I can then divide by 6. and I get 2 over 9 pi. So that's my central angle. Then I just multiply that by the radius, which is 20. So now I'm going to go over here. So I'm going to have S equals 2 pi over 9 times 20. And I'm going to get 40. Oh, wait, that's not a 9. What am I thinking? That's a 3. That's a 3. That's going to be 40 pi over 3. And look, that's the same answer that I did with my arc length, leaving the answer in pi. So this equation is just wrapping up the conversion of the degree into the radian. And that conversion is the 2 pi and the 360, because 2 pi over 360 is the same thing as pi over 180, and that's the conversion I used in the first step. So these equations are the same. They're just one's in radians, which is this one, one's in degrees, which is this one, and if I use each one appropriately, I get the exact same answer. Okay, so to recap, we got our learning goals. Can I convert radians to degrees and vice versa? And can I find arc length of a circle? So good luck with this.